diagram is useful. We've got 40 degrees to the horizontal, A and B are 3 meters apart on inclined plane. We can see that. Now this is crucial. A particle P of mass m is held at rest at plane A, and the coefficient of friction between P and the plane is 1/2, and the particle is released. Find the acceleration of P down the plane. So let's start off with there's friction. So remember, we've got a friction here, and we've got a normal reaction because there's a weight on the plane. What things are we going to need to use? F equals ma, and F max equals mu r. So we know F max, the maximum friction, is going to be 1/2 r. What else could we do? Well, we know r equals mg cos 40. That's the only perpendicular force acting down the plane, perpendicular to the plane, I mean. So that's step 1. Parallel, and use that as a positive direction because it's going to be sliding down. So what do we have? We have mg sine 40 minus rf, that's our forces, equals our m mass times acceleration. Now our friction here, that is our friction, which will hit F max when it's sliding down the plane. That's what we've got to work out. So our F max, right over here, or our friction, our F max is going to equal mu 1/2 times our r, which is our F here. So what do we get? We get mg sine 40 minus 1/2 mg cos 40 equals ma. Every term has m, so we can divide out by m. So we get left with g, which is 9.8, sine 40 minus, that's 4. Part B, it says speed of P at B. So here we go. We've got a distance of 3. We want a speed, so we want v. This is what we want. U starts at rest, is 0. Now we have A as well, 2.55. Out of all the SUVAT formulas, what can we use? That's got to be v squared equals u squared plus 2as. Substitute that all out in, so v squared equals 2 times 2.55 times 3, and then we can calculate to v to be 3.91 meters per second, and that's your 2 out of 2. Just going to show you the mark scheme for that question. For this, just going to show you the mark scheme for this question. So we can write this up. We can find our r. This is called a B1 mark. Using F equals mu r. So if we use this somewhere, we get a B1 mark, but we've got to use it, which is essentially doing this, resolving our forces. That's our method mark and answer mark here, and once we work this all out, that is another answer mark. So that is achievable. For part B, using this is your method and that is your answer. Now here's a similar question for you to try yourself. Pause the video right now If you got that correct, look at your A, look at your B, well done. That is a big 7 marks, and you can do this. This is in your pocket. Just remember, it's particles down a plane, it's not moments. Let's not confuse ourselves. Well done. Okay, let's look at this 13 mark question that is doable for us all. Just gonna go through what are the key points. We are going to need to use this information. This is just generally a part of the question, which is quite clear. So when you see the word projected, that's pretty clear that this question has got to do with projectiles. This is lovely. It is on the diagram, makes it nice and easy. We know we have two unknowns, u and theta, which we'll probably have to work out later, which you can see here. And at time t equals 2 seconds, P and Q collide. When they give information, we generally have to use it. So until they collide, the balls are modelled as particles moving freely under gravity. So we've got to use gravity. And it says, part A, find the velocity of P at the instant before it collides with Q. 6 marks. How could we break this down? Make sure we get all the method marks that we can, even if we make a mistake. So, let's have a look. Let's not make a mistake here. Look at, this is our adjacent, so that must be 20 cos 30. Up is our opposite to the angle, so that's 20 sine 30. Students can mix this up, and that will really cost us a lot of marks. Again, this has got to be u cos theta. Let's fill this all in. U sine theta, because that's going to help us. Now, let's get our irrelevant. Let's say our x, and we'll resolve in p. So that's our px. That's clearly this way. So what information do we have? We have t equals 2. We know the initial, because time starts at 0, is 20 cos 30. A is 0 in this instance, yes, because A is going up or down. And we need to find V. Let's start with this. This helps us know what SUVAT formula to use, or the easiest one to use. So, it's clearly this one. So let's use V equals U plus AT. So our V horizontally, which I should call VP, let's just call it VPX. That's just going to be 10 root 3. Now cos 30 I think is root 3 over 2. Now I'm pretty sure that gets you a method mark. Or you could just write 20 cos 30 if you don't jump to that solution. So for projectiles, we always resolve, and it's P vertically and horizontally. So this time we have A equals minus 9.8. If you can remember this, you don't need to write this all down, but it really sometimes helps you lay out your work, realise what formulas to use, and so you're less likely to make a mistake. We're still trying to find V, so we're still using V equals A U plus AT. So that's your VPY equals U plus AT. Let's work that out. So in the PY direction, make that clearly look like a V. So that's sine 30 is a half, but I'm going to write this all out. It is plus AT, so that's going to make it minus 9.8 times 2. Now we can now work that out as minus 9.6. So all that means is, so you don't get confused, is if this particle is travelling like this, it's probably going to collide with Q on the way down. Okay. Now if we just draw a triangle of this, that's your angle. This is your 10 root 3. This is your minus 9.6. Adjacent and opposite. So we know tan theta equals minus 9.6 over 10 root 3. Now this is in the mark scheme. It doesn't ask for the angle to the horizontal, but in the answer scheme it is, so that's why I'm including this, because technically if you want this velocity here, you can see we use Pythagoras theorem, but I'm going to show you everything to get your 6 out of 6 marks. So if we inverse tan, not theta, inverse tan minus 9.6 over 10 root 3 equals minus 28.998, and we can just round that to 29 degrees. Use our Pythagoras, so 10 root 3 all squared plus our minus 9.6 all squared, square root this for v, or our speed at this point, so which gives us the answer of 19.8 meters per second. At, obviously that is 29 degrees to the horizontal, at 29 degrees to the horizontal. Now let me show you how you get your marks, because this is really important. You get your M1 for doing this. Now for using your time equals 2 correctly, you get another mark which kind of appears here, so let's call that your method, and your accuracy mark up to here. This stage gets you another method mark, which is here. You can see using Pythagoras is your method mark, and there's your accuracy. That's your 6 out of 6. It is achievable. Now we're looking at part B. Now I think if you can answer this type of question, you're probably an A-star mechanics student. Lots of skills that you have to apply. So I would say this question is very challenging. We know that the total distance will be 50 meters. They both travel when they collide. Okay, because if you think about it, if A to B is 50 and they collide somewhere like here, imagine they collide here, they're going to travel 50 meters. Now they collide at S equals 50. The total distance is S equals 50, T equals 2. Now this is a lot of problem solving here, because you might think, well, we know, let's start with which way we're resolving. Let's resolve across. But we have to think what is happening in this question. So if the total distance they both travel is 50, that is, we've got to work with particle P plus particle Q horizontally equals 50. Okay. Now, A equals 0 here. Just want to know how far it travels horizontally. But we do use this. But if you think about it, you know, if speed equals distance, equals speed times time. S is not speed. So that means this is S equals ut, because there's no acceleration. S equals ut here, but in terms of P and Q. So from before, our particle P is distance travelled is going to be 20 cos 30 times 2, which will give us 40 cos 30. Our Q is now, we take this way as positive for Q because that's the distance it travels. That's going to be S equals 2 times U cos theta. Okay, for this is, let's call that SQ, SP, SQ. Okay, so our SP plus SQ equals 50. Like so. We've got something to work with. We've earned some method marks so far. What else can we do? Now you're going to get a method mark for saying, well, when they collide here, what are the vertical distances of both? They're the same, aren't they? So you get a method mark for writing vertical distance is equal, or vertical distances are equal for particle P and Q, for P and Q. Now how do we find vertical distance? Well, if we're going to use U, we have U's for P, so we're resolving up now. We know that's 20 sine 30. UQ is U sine theta. Now you can see what's going to happen. We're going to have to pull and use a simultaneous equation, but can we see we've got sine and cos, and sine divided by cos is tan, so this hopefully will work out right. But remember, when we act vertically we have acceleration, which is going to be minus 9.8. But we still have to use our S equals ut plus a half AT squared, because we have t in this question, we have u. So our SP upwards is going to be 20 sine 30 times 2, I'm going to write that here because that's your ut, minus a half A, because A is minus 9.8, so 9.8 over 2 times your t squared, which is 4. Your SQ is going to be 2 times sine theta, because remember we're using S equals ut plus a half AT squared minus 9.8 over 2 times t squared, which is 4. Okay, we're getting there now. We've said vertical distance are equal, so we can set this equal to each other. Now if we set this equal to each other, we're going to get 40 sine 30 minus 4.9 times 4 equals our 2u sine theta minus 4.9 times 4. Now if we rearrange, we plus this over, that cancels out and we can divide both sides by 2. We are actually going to get 20 sine 30 equals u sine theta with some rearranging. Hopefully you can see that. Now can we see we've got a u sine theta here? Can we make this divide by 2 both sides? So we're going to get 20 cos 30 plus u cos theta equals 25. We want our u cos theta on its own, so u cos theta is going to equal 25 minus 20 cos 30. Now let's call that equation 1. That equation. So I'm going to make this nice and clear. So I'm going to rewrite our equation 1 as u cos theta equals 25 minus 20 cos 30. Now remember our equation 2 at the bottom. Let's write the u sine theta on this side. I'm talking about this formula here. Equals 20 sine 30. Lots of algebra involved in this, so just be careful when you're writing things down. So if you think, if we do 2 divided by 1, we all know what we get. U's will cancel, so we get left with tan theta, because that's our aim, to find theta, equals 20 sine 30 over 25 minus 20 cos 30. Type that into our calculator carefully. Of course, we've got to do your inverse tan of all this. Okay, and we should get theta equals 52.5. That is good. That is some marks. Excellent work. Now once we have theta 52.5, our final answer mark should be easy. We can use equation 1 or 2, but I'm going to use equation 2. Sub in into 2. So we're just going to get u sine 52.5. Remember to make sure your calculator is in degree mode. You should really write your degree in to show you're working in degrees, although it is obvious with that number. But anyhow, equals 20 sine 30. Rearrange for u equals 20 sine 30 over sine 52.5, and you should get a u of 12.6. and you'll finally, if you realise that the sum of horizontal distances is 50, and that makes m equals your method 1, but it's implied that you do this, so that is your answer 1, your accuracy 1. And then you say, if you say vertical distance are equal, that's your method 1. Rearranging all here to get to roughly here. That's your accuracy. Solving for both mu and theta, well, that's what you're doing here, so that's your method, and your A1 is for both, it seems. Any of these limitations will get 1 mark. Please write a nice full sentence so you get and guarantee your last mark of 1. Nice easy mark to get. I suggest you practice this and try this again in the future because it's using the algebra. Right, so here is another question with different numbers that I've made, and give it a go because the skills are the same, and see if you can do it. Pause the video, have a go. I'm going to show you the answers now. That is part A. I'm gonna now go to part B. That's the answer for part B. Just saying that the final answer of 87 would make sense because at t equals 3 seconds, your SP, your distance horizontally from P, is 57.45 meters. So let me highlight this. So this bit is separate from the rest, and that would make sense that that angle of collision has to be quite high, the angle at theta for Q. Well, if you could do that and get that right, well done. This is a particularly challenging question, but I believe that you can get an A or A star in mechanics with practice, so that's why I'm showing you this.